Good morning, everyone.
Yeah, hi, good morning, Jason. Good morning, everyone. Can you hear me? How's everybody? Can you hear me?
I can definitely hear you. Everybody else respond.
Okay, okay. Hey, how are you?
Morning.
Yeah, good morning. Good morning, Novia. Uh, all right. Actually, today is the last last collaborate session of this semester because on the 13th, Monday, um, we're going to be meeting face to face. Um, I don't know. There seems to be some. I don't think there's any confusion between us, but the departmental secretary is saying that um, the in-person day is like December 19th or something like. I just don't. You
I
know,
believe it was the 20th.
where did you see that? I don't see uh, Jason.
I seen it on the
CUNY
on one.
first? Huh?
Yeah, I seen it on my schedule on the CUNY first.
Okay. I don't have any access to that. I don't on CUNY first, so that's kind of ridiculous. But I have been emailing you, sending out announcement um, all this time. That is the 13th because that's the last day of class. So there is no point in, think about it. 13th is the last day of class, not classes, all the classes. 13th is the last day of all the classes. So then after that, 1 week is, for exam. But you are doing the exam online. So the exam will have already been done. And then after that, there's no reason for anyone to come to school. So that may have been just administratively set prior to the beginning of the semester, administratively set, in June. So after that, I had no idea. But it's too late now. I mean, I cannot change. Everybody has been informed that the in-person class will be Monday the 13th. So uh, that's it. It will only exacerbate the confusion if we change it back. If we change it to the 20th. And by then, who's coming to school? After all the final is done, who's coming to school? It's time to just wait for your grade. Okay, so I hope there is no confusion here. Uh, we don't have any class on the 20th, right? Last day of classes is the 13th. That's official. Uh, unless you are just unless you just want to come on the 20th just to check out the building, right? Oh, this is BMCC. This is the building. This is Fitterman Hall. This is Murray Building. I mean, if unless that's the purpose, I don't think there's any point in coming on the 20th. Uh, and after once the final is done, it's done, right? Alrighty. So what was our last? What did I talk about in the last class? Hey, good morning, everyone. And how is this calculated? This is a okay. Any questions? Oh, okay. And a half year rate will be peso. You want me to take? Okay. So in our last class, we talked about how to value zero coupon bond, and zero coupon bond is easy, as we know. Zero coupon bond is a straightforward single present value of the single cash flow. But now let's think about the coupon bond. And we already know this is not a bond has 10 years to, let's take a look at this example. A bond has 10 years to maturity, a par value of 1,000, and a coupon rate of 10%. So that in that case, think about it. Our timeline, of course, the bond is on semi-annual cycle, but just for simplicity, to make it, just for simplicity, we'll assume, let's assume, annual cycle. In other words, coupon is paid annually. Okay, and if that's the case, a 10-year bond, par value is always 1,000. A coupon rate of 10%. That means, every year, at the end of every year, you will receive 10% of the par value. So coupon payment is $100.
100?
Yeah, the coupon payment is 100 because it's 10% of 1,000. So you get annually 100, 10 of them, right? And it's an ordinary annuity because, it will be paid at the end of each year. I mean, think about it. Interest is paid at the end. There is no one that pays interest up front. I mean, right? No bank that pays interest up front. In a simple discount, we use, the concept used in the simple discount is kind of, interest up front, in a way. But so then think about it. And at the end of year 10, you receive the maturity value or par value of 1,000. So then, all these $100, right, which are paid at regular interval. So the regular amount paid at regular interval. This type of cash flow, we have a name for it, right? Does anyone remember the name? Anybody? We already know this. And if you, Cora, are you there, Cora? Cora?
Yes, Professor.
Yeah, hi, Cora. So what do you think? I mean, this type of cash flow, right? Regular amount at regular interval, right? What is this? What is the name for this type of cash flow? What's the name? You remember?
I don't think I do.
Oh, Cora, please,
I was thinking capital gain, but that's probably not the answer.
No, not capital gains. This is clearly interest payment, so it's not capital gains. Huh?
Interest
Capital gains. Capital
No.
gain is something like, when you buy this bond, you don't pay 1,000. You will pay something like, $900 or whatever. You may pay, you understand the bond doesn't sell at par value. They sell either above par value or below par value. And if they sell above par value, it's called premium bond. If it sells below par value, it's called discount bond, right? And rarely there are times when bond sells at par value. But that's But you already know why the bond sells above par value, under what conditions it sells above par value, under what conditions it sells below par value. You know what? We've done that exercise over and over. Uh, what makes the bond a premium bond? What makes a bond a discount bond? And through all these examples, right? Through all these examples, we did that. Okay, so Cora cannot answer that, so I'll have to skip to the next person. Oh, there's Christian. Are you there, Christian? Christian? No. Felicia, are you there, Felicia?
Yes,
Felicia?
I'm here.
Yeah, hi, Felicia.
Hi.
So, hi. So can you answer this question? Hmm? What would be the what's it called? This type of cash flow, right? Regular amount and regular interval. That's the characteristics of something we already learned. What's it called?
Is it the face value?
No. Face value is par value of the bond. Face value is $1,000 all the time,
Is
right?
it an annuity?
Yeah. Who said that, Natasha? Right? Was it Natasha?
Yeah, I did.
Okay, Natasha. So you got 0.25 for that. Yes, it's called
Thank you.
annuity. Of course. It's called annuity, right? Didn't we talk about, I mean, the last topic, wasn't the last topic basically annuity? You know, it was,
Yes, that's right. It was annuity.
yeah, time value of money. And there are two types of, models, single cash flow model and um, multiple cash flow model. And multiple cash flow model, a single cash flow model is, straightforward, present value, future value, right? And then multiple cash flow model um, it breaks down into largely two types. One is just free form, right? Free form. It has, uneven, um, irregular, you just make sporadic deposits or sporadic payments, and each time the interest rate is different. That's free form, right? And there's no regularity to be found in that kind of model. So uh, there is no, you'll just have to compound it by different amount, by different interest rates, uh, and add them all together. So there is nothing, systematic. There is some system going there, but nothing, systematic through and through. The other one is, annuity. Annuity is, a regular payment or deposit at regular interval, right? So isn't that's exactly annuity. So now we understand, we know how to find the uh, bond price. See, um, these are annuities, right? And this 1,000 is a single cash, right? Single cash flow. So we know, given the discount rate, if you only know the discount rate, then we can find the bond price because it's the um, combination, right? Um, one thing is, one part is the present value of the annuity of all those payments, and then the other part is the present value of the single cash flow. We just need to combine that, right? So bond price is basically the present value of all those coupons, which are annuities, and then present value of the face value, $1,000 face value, right? So then this is not a difficult thing. Uh, just given just given the if only we are given the discount rate, we can do it. So here, let's take a look at this example. Consider 20-year bond. Why is it? Consider 20-year bond with 7% coupon rate. If the discount rate is 6% annually, timeline appears as this. Now think about it. First of all, even before doing anything, we can tell if this is going to be a premium bond or discount bond, even before doing anything. Okay, so can anybody guess? I mean, it's not just a guess, it's an educated guess, not just a wild guess, but educated guess. Can anybody form an educated guess about whether it's going to be a premium bond or a discount bond? Anyone? Is it going to be a discount bond or premium bond? So the last time I stopped with Felicia, Jason.
Is it premium?
Premium. Cora already said premium. Yes, Cora, it's a premium bond. But do you have any? Cora, you got already 0.25. But if you can provide a rationale, the reasoning behind it. If you can provide a rationale or reasoning behind it, this is going to be a 0.5 point problem.
I just knew it wasn't a discounted bond, because don't discounted bonds have like a higher percentage of a discount rate?
Oh yeah. You are. Did everyone? I need to clean it up a little, right? We need to clean it up a little. But did everyone hear her? Cora said,
Yes.
for that to be a discount bond, I mean, not discounted bond, but discount bond, right? Of course, all the bonds, all the bond prices are basically discounted cash flow, right? Discounted future cash flow, bond or stock. The price of any financial asset is basically the present value of all the future cash flows, right? So if you say discounted bond, I mean every bond price is discounted. It's the process. But discount bond. What's the definition of discount bond? Discount bond is the bond that sells below par value. I already explained it. I just get tired, repeating it over and over. And premium bond is the bond that sells above par value of 1,000, right? And what Cora said as reasoning or rationale, she said, for it to be a discount bond, the discount rate must be higher. Okay, that's what you said, basically. Isn't that right, Cora?
Yes.
Mm-hmm. And then for it to be a discount rate, I mean, the discount rate should be higher than what? It should be higher than what? Discount rate should be higher than what? Say that again?
20% or 15%?
No. I mean, 20% is really, really high discount rate. But but then there's a clue there. Higher than what? Anyone can pick it up from there? Anyone? Jason,
higher than 7%.
Yes. For that to be a discount bond, right?
That's right. For it to be a discount bond, it has to be higher than 7%.
Right. It has to be higher than the coupon rate, right? For the bond to sell at discount, right? The discount rate must be higher than 7%.
Right.
Now, in this case, and what is the discount rate? And I've been telling you over and over, this is not the way it is normally worded.
The discount rate is 6%.
I know, but it is not the way it is normally worded. I've been telling you. No problems says, no problem. What happened? Okay, I accidentally touched something. No, I've been telling you, no problem puts it straightforward. No problem says, this is the discount rate. No problem says that. And I told you there are roughly three ways it is worded. The first way it is worded is that the bond is priced to yield 6%. This bond is priced to yield 6%. Okay? Price to yield 6%. Or, second way it is worded, comparable bonds or similar bonds are paying 6%. Okay? Third way it is worded is that the prevailing interest rate in the market is 6%. These are three typical ways it is worded, and they will never say it straightforward that the use this as discount rate. They will never say this is the discount rate. So this is an exception, and I put it that way just because this is an example, as an illustration. Okay, but we can tell this is going to be a premium bond because coupon rate is higher than the discount rate. And then think about it. If the coupon rate is equal to the discount rate, it will always be selling at par value of 1,000, right? Why? Think about it. All those, it's going to be $60. I mean, if the coupon rate is 60%, it's going to be $60 every year. And, through and through for 10 years, $60. And if you discount it by 6%, it will be, and, the face value being discounted to by 6% for 10 years, they will exactly equal to only $1,000. Think about it. It's like this. Think about a single cash flow problem. Suppose the interest rate is 6% and you put $1,000 in the bank, and for 10 years, you put it in the bank. 10 years later, it's going to grow to what? 1,000 times 1.06 raised to 10, right? Whatever it grows to, right? And let me just, quickly give you an example. So think about it. If you put $1,000, and if the bank interest rate is 6%, it's going to be 1.06 raised to 10. So that's going to be 10 years. And it's going to be like that 10 years later. But suppose you are discounting it 10 years back by 6%. What's it going to be? If you're discounting it by 1.06 raised to 10, what's it going to be? Anyone? Think about it. This is the result of compounding it by 1.06 raised to 10. Suppose you are discounting it back to present, right? Back to time zero by 6% for 10 years. What should it be? Anyone? Jared, are you there, Jared?
Yes, but I'm not sure.
Oh, Jared, this is something you can be very sure. Michelle, are you there? Michelle? Get Natasha, are you there?
Wouldn't it be the number you were showing, or is it that calculation?
Yeah, what number are you talking about?
That one.
No, this one is the future value of $1,000 for if the interest rate is 6%. If you put it in the bank for 10 years, then it's going to be this. That's the future value. But my question was, So then if you discount it by 6% for 10 years, if you discount it back to present, back to time zero, at 6% for 10 years, what's it going to be?
1,000?
Yeah, who said that?
Gerard.
Gerard. Yes, of course, it's just going to be.
That would mean the present value would have been 1,000. Okay, that makes sense.
It would be. It would be. Would have, not would have been. It will be. Right? So, Gerard, you got 0.25. Yes, of course. Think about it. You got to this by compounding at 6% for 10 years. But then if you discount it at 6% for 10 years, then you will go back to 1,000. Isn't that right? That's only, it's the same idea, right? If you divide this by 1.06 raised to 10, then what else can it be? It will be just 1,000. And it's the same idea. Think about it. If the coupon rate is 6% and the discount rate is 6%, right? Then if you discount it all the way to present, right? Then it will only be $1,000. It will have to be $1,000, right? Whatever, that's why if they are the same, if the coupon rate and the discount rate are the same, right? It will be exactly par value bond. But if the coupon rate is greater than the discount rate, you are, in other words, under discounting, right? All the future cash flows. Therefore, the present value will have to be greater than 1,000, right? Mathematically, that's why. Okay. And then if coupon rate is less than the discount rate, then you will be over discounting, so the present value will be less than 1,000. That's mathematically why. Also, I've been explaining it like this. If this bond pays higher coupon interest than the discount rate, and what did I say discount rate is? Discount rate is the average, the prevailing market rate. Prevailing market rate means that's what the average, what the bonds of the similar risk class, bonds of the similar or comparable, I said similar or comparable bonds are paying 6%. What does that mean? Bonds of the same risk class are paying 6%. So that means on average, if the bonds of other bonds in the same risk class are paying 6% on average, this bond alone pays 7%. Obviously, there's going to be a huge demand for this bond. I mean, why would you put your money into other bonds that pay 6%? You will put your money in this bond, which pays at least 1% more. And what's going to happen to the price of the bond? This will drive up the price of the bond, right? And therefore, it will end up being a premium bond, right? Do you remember that? And the opposite is true for discount bond. So that's how, that's why and how the it becomes, discount bond or premium bond. And so now we understand, and here, right, as you look at the timeline, you find something weird. Wasn't it 20 years? Why is it 40? That's not 40 years. That's, look, 40 semi-annual periods. In other words, 40 semesters. And you see why? Because bonds are on semi-annual cycle, right? Bonds pay coupon interest semi-annually every 6 months, right? Therefore, uh, 40 periods, and then annually it will pay $70 because 7% coupon rate, but they pay every 6 months, so semi-annually it's going to be $35. Does that make sense? 35, 35, 35. Mhm. So then if we plug in those numbers into this formula, right, we'll do that. We'll do that on Excel. We'll do that on Excel. So I want you to open this file. Where is it? If you go to the topics folder, right? If you go to our topics folder, there is a file named bond valuation, right? So please open it. Do you have it in front of you?
Yes.
Okay, good. So first, I believe these, when you open it, all the highlighted cells must be blank, right? Are the highlighted cells blank? Are they blank?
Yeah.
Okay, good. So now then, we're gonna do the so I want go to row 8. Go to row 8. Okay. So this is exactly our example. Everyone has it in front of you. Okay. I want just to make sure. Cora, do you have it in front of you? Cora?
Yes.
Okay, good. Jason, you have it in front of you? Jason? Jared,
Yeah,
Yes.
you
yep,
have it?
I got
Okay, good. Jordan, you have it in front of you? Jordan?
Yeah,
Michelle,
hello.
do you? Okay,
Hello.
good. Michelle, do you have it in front of you, Michelle?
Yes, I have it.
Good. Natasha, you have it? Do you have it, Natasha?
Yeah.
Okay, good. Novia, do you have it?
Yes.
Novia? Okay, good. All right, let's get to it. So this is exactly our example. Why? Of course, all the bonds have $1,000 face value. Of course, you got to remember, not the municipal bonds, right? But otherwise, it's all coupon rate 7%. M is the compounding frequency, so it has to be 2 because it's semi-annual. This is the discount rate. Discount rate should be called, yield to maturity. Yield, it should be called yield, but for now, we'll call it, because it's annual rate, right? Annual. And of course, this is the periodic rate. Every 6 months, half year, it should be 3%. So first, we can calculate the payment, coupon payment. It's 1,000 times 7%, but that's only for 1 year. That's for 1 year. For 6 months, you'll need to divide it by 2. Right, there you go, 35. And timeline is 20 years, but it's got to be 40 semesters because, actual number of compounding is going to be T times M, right? Annual discount rate is 6%, but this must be divided by 2. So every 6 months, It's going to be 3%. Now we find the price of the bond, right? So it's going to be payment using, present value of annuity formula and the present value of single cash flow. So payment over R minus payment over, open parenthesis, R times 1 plus R raised to N, close parenthesis. Now that's the annuities alone, right? The coupon payments. That's the present value of the coupon payments alone. In other words, only this part, right? Then we need to do this. So plus face value divided by 1 plus R raised to. Okay? If you're okay up to this point, hit enter and tell me what you got. Hit enter and tell me what you got. Anyone found the answer? This would make so much attention to it. Already lost the hour. Come on, if you are you all good up to this point?
I'm not. I'm just working on it right now.
Okay, but has anyone found the answer yet? Oh, there are 8. How many people there? There are like how many people are there? We have like 8 people. Out of 8 people, no one got the answer yet. How about you, Novia? Cora, how about you, Cora? Have you got the answer yet?
Mine came out to 1,115.57.
Yeah, that should be correct. That's correct. Well, let's just let's just check it, right? So you hit enter. Yeah, $1,115.50. Of course, you got it right. And didn't it confirm our previous assumption? What was our previous assumption? This is going to be a premium bond, right? This is going to be a premium bond. So how did it come out? Isn't this a premium bond? Isn't this a premium bond or not?
Yes.
Yes, it's a premium bond. So it confirmed our assumption. I mean, it wasn't just an assumption. It was an educated guess, right? Yeah, so you got it right. So everyone got this number?
Yes.
Everyone? Okay. So now let's go to row 4. What is this? It looks like, $1,000 face value. So every bond has 1,000. Coupon rate is 7%, and all the bonds have, compounding frequency of 2 because it's on, semi-annual cycle. Yield to maturity, which is the discount rate. Yield to maturity is 8.8. It was already given. Where did I get this from? I'll tell you. And then half year rate. Half year rate is this because it's simply that divided by, right? And the bond price is given. So what is this problem? This problem is not about the bond price. It's about years, right? How many years, right? Where did I get this from? Do you remember at the beginning, right? When we did the bond price quotation in the print media, do you remember this CIT group, the corporate bond? Look, CIT group, coupon rate 7%. Excuse me. Maturity date,
Bless you.
May. Thank you. May 2016. Last price 91.735, but you know this is percentage price, percentage of par value. So it's actually $917.35. Yield 8.838. That's exactly that data, right? I got the data from here. And why? Why am I doing that? I told you at the time that this example was taken in 2010. How do I know? I told you I traced it back by calculating years, by calculating N, right? Do you remember that? Yeah, I didn't trace it back by, actually looking up the, the newspaper that this was printed on. I don't know. How do I know? I mean, how far do I need to go back? I mean, if I were to search the newspaper, then, what do I pick? Wall Street Journal, New York Times, and, money section. But, obviously because maturity was 2016, and and even this one maturity was 2013. So, I start the search from like February of before January of 2013 and go all the way back, until I find this exact price and this exact yield. That would be a tedious job, and that's not a smart way of doing it, right? So I calculated N. That's why. So, and that's how I could come to a conclusion that this example was taken in 2010. So let's see how we can find it. So here, so our quest is to find N. Okay, and here we need to know. Okay, the payment is. First of all, we will need to fill in a couple of things. The payment is, it will be $35, of course, because it's 7%, and divided by 2, that's $35, right? So our unknown is N, and then once we find this, we can convert it into years, right? And then if we convert it into years, because we know the maturity date, we can subtract then that number of years from this maturity date, and we can find time 0, which is when this example was adapted. Okay. So to find then, we can use natural log, blah blah blah, but just to make it easier, we can use N period formula from Excel. So we go to, and then find N period, right? There's N period, and give it what is asking for. Rate means the discount rate here. That's the periodic rate. And basically the yield to maturity is the rate that makes this is the left-hand side of the equation, because in the left-hand side you will have present value, and equal to the right-hand side, which is the old cash flows discounted, right? Payment here, present value, this is the present value, but don't forget, you must enter it as negative. I don't know if it, do you see the number as negative in there or positive? If it is negative, you don't have to, you can just click it in. You don't have to put another negative sign, another minus sign. What is it like? Do you have this number as negative or just as positive?
It's positive.
Okay, then you have to adjust it by putting a minus sign here in the dialog box, and the future value. Future value is this always. And then we already get something here. Hit OK, 11.71. Did you get that? Did everyone get that?
Yes, I got it.
Okay. So that's 11.71 semesters. 11.71 semesters. So in years, all you need to do is just divide that by 2. So it's 5.86 years. 5.86 years. All right.
That's
then,
correct. I got it.
Okay, good. Then we can trace it back to time 0. We can trace. So from May 2016, you subtract this. But look, you cannot just subtract it like that because Excel doesn't know if it is years or days, right? And the calendar dates on Excel is based on all days, counting the number of days. So it's like this, on Excel, time 0 is January 1st of 1900. That's on all computers, right? All the computers' clocks, right? Computers' clocks are set to January 1st of 1900 as the beginning of time. Okay, that's how the computer, and then every future date is basically simply adding the number of days to that January 1st, 1900. Any previous past date, like, 1771, it's just, that January 1st, 1900 minus number of days, right? So everything works by number of days, so you must multiply it by 365. Hit enter. It gives you what? June of 2010. And that's how I could trace it back to June of 2010. Okay, make sense? So
Yes.
everyone is
Makes
okay?
sense.
Okay, everyone is okay up to this point. If you have any questions, it's time to ask now. Don't let it just, don't let it just sweep under the carpet, right? Don't just sweep it under the rug. Huh?
That's right. Don't let it sweep under the rug. That's right.
So everyone got the same result?
Yes, I did.
Okay, and I will take that as yes. So then, now let's go over to the next example. And the next example is row 12. Let's do this. And we have $35 payment, so it must be 7% coupon rate. Time left maturity is 8 years, so that's 16 semesters. Our question is, so what is R, the periodic rate, and what is the yield to maturity? So I think what we need is actually, I must have switched this. This should be olive. This should be, okay, but let me check what time it is. Okay, it's 11:40, 54, almost 55. So I think this is, it's just about, let's do this first. Okay, let's do this first. And after that, we will, we'll take a break. So price of the bond is given. Now, think about it. I'm talking about what yield to maturity is. Yield to maturity is basically annualized return. So I think I better talk about this. It's gonna take some time, so I think I better talk about this after the break. So we'll take a 10-minute break and reconvene at 12:05. Okay. All righty. 10 minutes.
Professor, are you there?
All right, we're back. We're back. Um,
Professor, can I ask a
yeah,
question
yeah,
real quick?
yeah, sure.
So, like before when you sent the email about the vaccine, like in my area, it takes about 2 weeks to get an appointment for a vaccine. So like I just got my vaccine yesterday,
Uh-huh.
and I was wondering if it was too late to submit it to CUNY first.
No, it's not. Was it the second dose or first
The
dose?
second dose.
Second dose. Do it immediately because if you don't, you might be, at risk of, getting a WA.
I
I
was
mean,
just
I
wondering,
haven't.
like it's 10 days. You said it's 10 days after the last class, or I mean before, right? Before or after?
They said 10 days before. So officially, the 10. I don't know what they will count as the last. I mean, our last class is Monday. But it's always better late than never. And do it as and then at least if you upload if you upload it today and then later even if you get WA then you can reverse it. You can appeal and reverse it, and then you will get whatever grade you get.
Okay, okay.
So
Thank you very much
officially,
for clearing it up.
yeah, you're welcome. You're welcome. Any other questions? All righty. So I just checked, this morning, and I have six classes, four of them are FMB 100, and the other two are FMB 230 and 300. None, I didn't find anyone in FMB 100 currently in WA, although I saw like five in 230 and 300, and they have been, alerted. I don't know. They have been reminded, so many times, and um, if they still don't take any action, then they are responsible. Okay. Um, all righty. So where was I? Okay. Um, so this one. Uh, So this is a question about finding yield. Yield is the basically the discount rate that makes this price, market price, equal to uh, the right hands, all the discounted cash flows in the. Uh, so let me put it this way. All right. So did I already do this? Somewhere here. Okay, here. Now let's think about it. We know price of the bond, and this is the rational price or intrinsic value or the fair value. What does that mean? Now think about it. Bond price is the result of discounting all the future cash flows to present, right? And in case of bond, there are, if it is stock, the future cash flow is, there are many ad hoc factors. In other words, there are many uh, volatile factors, right? That would determine the future cash flows. But in case of bond, the future cash flows are quite obvious. I mean, there is no ad hoc factor, right? In other words, that's the Latin word, ad hoc. Um, what's going on? That means, erratic. There is no erratic factor, unexpected erratic factor in the future cash flow in case of bond. Why? Because think about it. It's quite, predictable. It's quite, already predetermined. You will get the coupon payments for the entire duration, for the time until maturity, and then you will have $1,000 at the end of the maturity. So future cash flows are not quite variable. It's quite all the factors are predetermined. In case of stock, that is not like that predetermined or so. To find the price of the bond, all you need to have is the coupon payment, which are known, face value, which are known, time left, which are known, n is known, and if R is given, in other words, the discount rate is given, then all you need to do is, of course, discount rate will be, what is the prevailing rate for this bond category, for this risk category? What other bonds, similar bonds of this risk class are paying? Average of that. That will be the discount rate, right? And then we find this. So in other words, everything in the right-hand side is given, right? To determine the bond price, if this is the unknown, everything in the right-hand side is given. So, on the other hand, then we find the present value of the bond. So that's the price of the bond. It is called rational, because there is nothing irrational about this. Rationally, all the future cash flows are predicted, right? So we are finding we are doing this calculation within the predicted parameters, right? So this is the rational price, also called intrinsic value. That's the intrinsic value of this asset, and that's also called fair value. Now, but I've been telling you, the market in the short run is usually irrational, and the market price is not determined by this rational calculation, because how many of think about the stock. I mean, stock market participants, they just buy and sell and buy. They are average Joes. A lot of individual investors, not the institutional investors, but individual investors are just average Joes, and average Joes with no training in economics and finance. They just play it by ear. They just heard something from here, something from there. You understand? By a little tip from someone, by a little tip from another. In other words, that's all called noise. So when there's a massive sell-off, they just jump on the bandwagon. Massive buy, they just jump on the bandwagon. So in other words, this is what most of the individual investors are like. They don't know how to calculate the intrinsic value of the stock. They just, follow the herd, right? They just follow the herd mentality. So the price of the stock, the market price, is determined by demand and supply, and huge demand or huge supply or huge demand can result in a price that will be different from the rational price or intrinsic value. Make sense? In case of bond, it is less volatile. I mean, in case of bond, because as I said, there is hardly any ad hoc factor in bond. all the future cash flows are predictable, and it is exactly predicted. So the variation of the bond price is relatively smaller and less than the case of stock. But still, demand and supply will determine the market price. And because of that, in the short run, it may be misaligned, mispriced, meaning, the market price may not be the same thing as the rational price, okay, or the intrinsic value. But in that case, think about it. You cannot say, "Oh, this is not intrinsic value, so I'm not going to buy it. I'm not going to buy it at this price." If it is lower than the intrinsic value, then you would definitely buy, right? Because anything underpriced, how do you know if it is underpriced or overpriced? That means there must be a fair value, intrinsic value, right? With which you compare the market price. Isn't that right? So if it is below the intrinsic value, then the market has underpriced it. That's something to buy. It's a buy target. And if it is overpriced, it's a sell target. You don't buy it. And if you already have it, you sell. You must sell. So here's the idea. Even if the bond is overpriced, if you have to buy it, bond or stock is overpriced, if you have to buy it, you have to pay the market price. There's no other way around it, right? If you have to buy it, you have to pay the price. But then, so then in that case, the price is known, right? And then until maturity, you will receive coupon payments, and at maturity, you will receive the par value. So the point is then, this thing is known, right? This is known, this is known, this is known, this is known, and then there will be only one discount rate. There will be only one discount rate that will make the right-hand side equal to the left-hand side. Right? Makes sense? There can be only one value, one number for y, the discount rate, that will make the right-hand side, right-hand side equal to the left-hand side. Right? So what is that rate? What is that discount rate? Finding this rate, this rate is called internal rate of return. Internal rate of return means, the rate that makes the right-hand side equal to the left-hand side. Okay. So that's what yield is. Yield is, one. That's the discount rate, right? It's annualized return if you hold the bond until maturity, right? And then that is another interpretation of that is, yeah, that's what the bonds of the same risk class, other bonds of the same risk class are paying on average, right? And that's the prevailing rate for that risk class. Mathematically, it is the rate that makes the right-hand side of this equation equal to the left-hand side, right? So no matter what they say, it's a long-term yield, long-term return. Yeah, yield, and I told you, yield is another name for annualized return, annualized. So no matter what they say, how it is defined, mathematically it is only one thing. In this equation, left-hand side and the right-hand side are all known. The only thing then that is unknown is this discount rate, which, and this discount rate is the rate that makes the right-hand side equal to the left-hand side. Think about it. That's no matter no matter whether this is the fair value or not, if you are to buy the bond, you'll have to pay this price. And most of the times, the market price in the short run, is irrational. It is mispriced most of the time. In stock, especially. In bond, it is less frequent, right? But still, a market price may differ from the intrinsic value. So, and since market price is visible, I mean, you can look up market price from online media or print media, and then all you need to do is then since the price is given, then you will want to know then what is my if I hold it until maturity, what is my annualized return? And that annualized return is this discount rate. And that's the one that makes the left-hand side equal to the right-hand side. That's what yield is. Okay, so there's a whole section here dedicated to the concept of yield. Yield, right? And then there is so I'm going to get so without further ado, let's get to that. So now this bond is selling for $1,150. So this is a premium bond. This is a premium bond, right? And the reason you would understand if it is in the parenthesis or in the red font, that means this is negative. Of course, it doesn't really mean negative number. It simply means cash outflow because you have to pay this price to buy this bond. That's cash outflow. And over the next course of next 8 years, 16 semesters, you'll get $35 every semester. That's like, $70 every year for 8 years. And at the end of 8 years, you'll get 1,000. So our question is then, what is my annualized return? Well, first, you'll have to find the semi-annual return first, right? And we can already tell that this is going to be greater than 7%. How do we know? Because this is what? This is a premium bond. Isn't that right? The fact that this is a premium bond means coupon rate, the coupon rate, the yield must be lower than 7% because the only way this can be the premium bond is because the coupon rate is greater than the discount rate. Makes sense? So we can tell already that this will be less than 7%. Okay, so well, let's find out. And we know to do that, we will go to rate function, rate, and give it what it's asking for. N periods, N, payment, there you go. Present value, there you go. You don't have to put minus because it is already negative. Because it's already negative, you can enter it like that. Future value, that's the future value. There you go. We already got this. So hit OK. It comes to 2.36%. Everyone got this?
Yes.
Everyone got that? Okay, good. Then we turn it into annual rate. So yield to maturity. We simply multiply this by 2. Right? Comes to 4.73%. So didn't I say it would be less than 7%? right? So this is how you find. And there are two types of yield, and I don't know what this was given as, but I think there was a problem related to that here. Current yield. Oh, yeah, I think this is the example. So Emory Corporation issued an 8% 25-year bond 15 years ago. Okay, so that means only 10 years left now because it was 15 years ago, right? And it had, 25-year to maturity 15 years ago. So now it will have only 10 years left to maturity. And it was an 8% coupon. At the time of issue, it sold for its par value of 1,000. Now, from this clue, this is a clue. Oh, then what was the this prevailing market rate at the time then? If it sold at par value of $1,000, right? At the time of issue, that was 25 years ago. I mean, 15 years ago. At the time, it was selling at par value. Then what can you tell about the prevailing market rate at the time? In other words, what was the discount rate at the time? Or what was the yield? What was the yield to maturity at the time? Anybody? This will be, yeah. Anyone?
It was 10%? No, not
No, why 10%? Why 10%? Look, there is only one condition it will sell at par.
8%. 8%, I meant to say.
8%. Did you say 8%?
Yes, I did.
Okay. All right, Jason. So, Jason, yeah, you got 0.25 for that. Yes, 8%. Why? Because it will sell at par value, right? Only under one condition. If the coupon rate is the same as the discount rate, then it will be a par value, right? It will be a par value bond. So 15 years ago it was par value. So yield 15 years ago was 8%. That's what it said. Comparable bonds are yielding 10% today. Comparable bonds, that means this is the discount rate today, right? Remember, this is how it is worded. Comparable bonds are yielding 10% today. But this is the discount rate. And that means now this bond will be a discount bond or premium bond.
Discount bond.
Discount bond. Yeah. Who was that?
Cora.
Who said Cora? Cora, you got another 0.25. Yes. Now it will be a discount bond. Yes, of course. And I calculated. Yes, it's the discount. What must Emory's bond sell for in today's market to yield 10%? Yeah, that means this is, it's priced to yield 10%. That's the discount rate today. And what should it be the price? I found the price. And this confirms our educated guess, that it's going to be a discount bond. Yes. Assume the bond pays interest semi-annually and calculate the bond's current yield. What's the current yield? Current yield is, yield to maturity is, as I said, is the long-term annualized return, right? If you're holding it to maturity. I mean, even if you don't hold it to maturity, I mean, the calculation itself won't change. But then, since the yield to maturity is a long-term, what is the short-term? Short-term return. short-term return is called current yield. Current yield. And short-term means under 1 year. So maximum return you can get from holding the bond for 1 year, within 1 year timeline, within 1 year time frame, the maximum return you can make is actually just annual coupon payment. Isn't it right? The maximum you can make for holding it 1 year is just the annual coupon rate. So then how do you calculate the short-term return? Or simply annual coupon payment. Okay. Annual coupon payment divided by the price you paid. Divided by the price you paid. So it's easy. Current yield is very easy. So let's do that example. So here, yeah, that's 1,000. Oh, it's not exactly the same example, but we can make it. The coupon was what? 8%. Coupon was 8%. We can simply change that to. We'll do it. Okay, we'll just change that to 8%. Then the coupon payment will be $40, right? Time left maturity, 10 years, right? And then this was probably a different. Was probably a different. So now we are trying to find the rational price of the bond. So this is also, and then first. Using 10%, 10% was given, right? So this was a different example. So because discount rate is given, other bonds, similar bonds are paying 10% today. So, then of course, then this will be 5%, right? The bond price will be then, using the same formula, right? I'm gonna just copy this. Come on, I copy. I'll paste it here. What is that? Copy. Yeah, I told you this is going to be a discount bond, and then current yield will be current yield annual coupon payment, which is this times 2, right? Or you can simply do this times this. It will give you annual coupon payment divided by the price you pay. Okay, there you go. It will come to 9.14%. Okay. So you see, I'm using, I'm slightly changing the notation here. Actually, I use B, uppercase B, for intrinsic value of the bond, and P subscript B as the market price of the bond. But here, P subscript B was also used as the intrinsic value of the bond, because in this case, as I said, in case of bond, the market price won't be that much different from the intrinsic value or the rational price of the bond, because there aren't many irregular, erratic, ad hoc factors in the valuation in pricing of bond, because the future cash flow is quite straightforward and it is well predicted, right? So market price won't be that different from intrinsic value. Everyone got this? Did everyone get the same result?
I got the same thing.
Okay, good. How about the rest of the class?
Yes, I got that as well.
Okay,
Yeah.
good. All right, it looks like that's all the time we have. So I'll I will have to call it a day. Have a great afternoon, and I will see you guys on Monday. Please, do the, before coming to class, do the reading and watch the assigned videos for that day. Okay. All righty. I'll
Thank
see.
you very
I'll
much,
stop.
Professor.
All right.
감사합니다.
You're welcome.
Thank you,
Oh,
Professor.
you're welcome.
Thank you, Professor.
All right. Take care,
Yeah.
everyone.
See
I'll
you.
stop
See you the
sharing.
13th. 안녕히
Have a good one,
계세요.
Professor. I'll see you on
Yeah.
Monday.
Okay. I'll see you.
I'm
그날
gonna
봐.
email you
그날
later
봐요.
today or maybe tomorrow.
What?
I have some things to say.
Okay. Yeah. Go ahead.
No, but I'm
Was
driving
it
right now,
June?
so I can't really talk. So that's why I'm gonna send you an email.
Yeah. Send an email. Okay.
Alright,
Was
have a
it
good one.
June? Yeah. No. Yeah. Novia, you have something to say, Novia? Okay. All righty. I'll stop recording and sign out.